In this video, we'll take a look at using a standard algorithm for whole number multiplication. Recall that the students have been using an area model to visualize the components of the product, and we talked about how eventually this will allow students to connect partial products to an efficient algorithm, and that's what we are going to take a look at in this video. So on the left-hand side of the screen, you see a completed area model for multiplying 517 times 29. We're going to walk through using an algorithm to solve the same problem, and then we'll take a look at the connections between the two. Before we solve, it's important to estimate. So I'm going to go ahead and estimate the product. Just record that underneath here. We know 517 is close to 500. Remember, students should choose numbers that are easy to work with mentally when estimating. And 29 is close to 30. And I know that 500 times 30 would be 15,000. So I would expect that our answer will be around 15,000. So let's take a look at using the algorithm to solve. The first thing that we'll need to do is stack both of the factors on top of one another vertically. So I'm going to record 517 and then 29 underneath. We want the place values to be aligned like you see here. And now we're ready to multiply. The first thing that we do when we're using the standard algorithm for multiplying whole numbers, we begin in the ones place here with our 9, and we're going to multiply the 9 by each digit in 517. So we'll begin by doing 9 times 7, which is 63. I'll put the 3 in 63 down below the 9 times 7, and the 6 will go up here above the 1. Now I'm going to do 9 times 1, which is 9, plus 6 would give me 15. The 5 in 15 goes down below the 1 here, and the 1 in 15 comes up above the next digit I need to multiply 9 by, which is the 5. Now I will do 9 times 5, which is 45, plus the 1, and that is 46. And I can write all of 46 down below here, since I don't have any other numbers to multiply 9 by. I've multiplied 9 by the 7, the 1, and the 5. Now I'm ready to begin to multiply by the 2 in 29. Before I do that, though, there's a very important step, and that is that I need to put a placeholder 0 down in the ones place in the next row. That is because I'm getting ready to multiply by this 2, which is really in the tens place, really has a value of 20. Now, in a standard algorithm, we don't really need to be too concerned with the value of each digit. We just follow the steps of the algorithm and use our basic math facts. However, in this case, we do need to remember to put the placeholder 0, because what that will do is shift all of our digits one place value to the left, making them 10 times greater. So it will be like I really did multiply by 20, even though as I think through this, I'm just going to think 2 times 7 and 2 times 1 and 2 times 5. So we'll begin with 2 times 7. 2 times 7 is 14. So I'll put the 4 down below and bring the 1 up top. Now 2 times 1 is 2, plus 1 is 3. And lastly, 2 times 5, which is 10. And I can put all of the 10 down below since I don't have anything else to multiply the 2 by. I've multiplied 2 times 7, 2 times 1, and 2 times 5. So now I'll just add these two partial products together to find out our product. And I can see that the product is 14,993. So I'm going to record that up here, 14,993. Now, when I compare that to our estimated answer, we thought that our answer would be around 15,000. And I do know that 14,993 is really close to 15,000. So that lets me know that our answer is reasonable. Now, the purpose of having the area model on the left was so that we could point out the connections that we can see between the area model and its partial products and the algorithm. When you solve an area model, like you see here on the left, where you add together each of the partial products in a row, you're going to notice similarities between that and what you see in the standard algorithm. I'm going to draw a line here to connect, but you'll see that here we have 10,340 as a partial product, and we also have that right here in the standard algorithm. In the standard algorithm, we got 10,340 when we were multiplying 2, which was really 20, by 517. And you can see that we got that in our same step in our area model when we did 20 times the 517. You'll see that when I added the partial products in the row below that, I got 4,653. And you'll see I have that same partial product right here, 4,653. And that came from my first step of the algorithm when I was multiplying 9 times 517, which matches what I was doing here in the area model in that bottom row. So these are the types of connections we'd be looking for students to make between the partial products in their area model and what they see in the algorithm.